Good morning, children. In this class, we will study the function of the ear, that is, hearing as well as equilibrium. In the latter part of this lesson, we will observe the mechanism of hearing, how sound travels from the outer, middle, and inner ear to the brain. Students, before we start discussing the mechanism of hearing, I would like to ask you a question. Do you know how are sound waves produced and transferred? Sound waves are produced as a result of vibrations. I hope you all know this. Now, what are these vibrations and how are they produced? Think you are standing in front of a pond and you throw a pebble into the pond. What would you observe? You will find that there are ripples on the surface of the water which go to the end of the pond, hit the end of it, and then come back to disturb the next vibration that may come. Now suppose the outer surface was made of a membrane, then what would happen? These vibrations would have hit that end of the pond and then get neutralized there itself and would not disturb the next vibration that would come. The same thing happens in our ear also. Now with that in our mind, let us see the mechanism of hearing. When sound is produced, this sound reaches the external ear and the external ear pinna concentrates that into the auditory canal. The auditory canal receives these sound waves and transfers it to the eardrum, which lies at the end of the auditory canal. The eardrum starts vibrating and transfers it to the ear ossicles. The ear ossicles in their turn transfers it to the oval window, and the oval window starts vibrating. The oval window's vibration are then transferred to the perilymph of the sclera vestibuli. These vibrations are then transferred to the endolymph and the basilar membrane starts vibrating. This vibration stimulates the hair cells of the organ of Corti, which converts the sound waves into nerve impulses. The auditory nerve, which is the 8th cranial nerve, carries them to the brain. Children, to make you understand this whole thing better, I would like to show you a video.
Ears are constantly active. They pick up sound waves and change them into information that the brain can interpret, such as music or speech. Sound is a pressure wave that can vibrate either quickly or slowly. Slow vibrations produce deep sounds, while quick vibrations produce high-pitched sounds. Sound enters the ear and is directed through the ear canal, where it first reaches the eardrum. As the eardrum begins to vibrate, it sets the ossicular chain in motion. The ossicular chain consists of the hammer, anvil, and the stirrup. Sound vibrations move along the ossicular chain and into the inner ear. Within the inner ear, the cochlea plays a central role. It is here that the mechanical energy of sound is converted into complex electrical signals, which are then passed on to the brain. In simplified terms, the cochlea is a spiral-shaped tube filled with fluid. Sensory cells, also called hair cells, line the entire length of the cochlea. These hair cells have varying degrees of sensitivity for the detection of different tones or frequencies. This allows the ear to perceive the entire spectrum of sound. The change from mechanical vibration to electrical pulse is a complex process resulting from the movement of hair cells in the cochlea. Along the entire length of the cochlea, the hair cells are arranged like the keys of a piano. Hair cells located at the base or lower region of the cochlea are responsible for high frequency, while hair cells at the apex are responsible for the low frequencies. As the fluid in the cochlea is set in motion, it causes a corresponding movement of the fine structures on the surface of the hair cells to take place. These movements cause tension differences which produce electrical signals that are passed along the hearing nerve to the brain. The auditory cortex of the brain interprets this information as sound, for example as music or speech. The entire chain of events, including the various steps that convert sound waves from the environment into information that the brain can interpret, happens so fast that individuals can hear sound both continuously and instantaneously. Within this complex chain of events, there are a number of factors which can cause an individual to experience hearing loss. A loss of hearing can range from a mild to moderate hearing deficiency to a total hearing loss. In general, there are three main types of hearing loss which differ from one another depending on the part of the ear that is affected, be it the outer, middle, or inner ear.
Students, we know that the ear is also responsible for equilibrium. Basically, there are two types of equilibrium: dynamic equilibrium and static equilibrium. Dynamic equilibrium is equilibrium when we are in motion. The semicircular canals are responsible for dynamic equilibrium. There are three semicircular canals depicting the three planes, and if there is any movement in any of the three planes, the brain gets the signal for that through the sensory cells called cristae. Basically, it is responsible for rotational movement. For example, if you are turning round and round and then you suddenly stop, you feel dizzy because the endolymph rushes back from where it has started, and that gives you a feeling of dizziness. Static equilibrium. The vestibule is responsible for static equilibrium, that is equilibrium when you are at rest. In the vestibule, there are sensory cells called macula, which sends the message to the brain. It is also known as positional balance with respect to gravity. For example, if you are going in a lift and you suddenly move up in the vertical plane or suddenly move down in the vertical plane, you feel uneasy. It is because of this static equilibrium. I hope you have understood equilibrium also together with hearing. That is the end of the chapter. I hope, children, you have understood everything and will have no problem. But still, if you do have any problem, do let me know. Take good care of yourselves and your parents and everybody else in the household. Thank you and have a great day.